It's Friday morning. It's the AWS Developers Podcast. Today we're talking about cost optimization. Good morning, good afternoon, wherever you are on this planet. Thank you for downloading the AWS Developers Podcast. Today we're talking about cost optimization, taking care of your AWS bills and trying to reduce it, to analyze the variation, the source of the cost, and to take action on that with a service called AWS Compute Optimizer. And to talk about Compute Optimizer, I have the pleasure to welcome Rick Ock. I hope I pronounce your last name correctly, Rick. You're senior manager managing a team of product managers for cost optimization tools, including Compute Optimizer. What is it?
Yeah, hi. Thanks for welcoming me on the podcast. I'm excited to join today and talk about Compute Optimizer. So Compute Optimizer is actually a free tool within the AWS console where you can enable it, and it will look at all of the historical utilization and data and performance of your EC2, EBS, ECS tasks, RDS, Aurora resources over time. And then it'll help make resourcing decisions on those resources. And what's a resourcing decision? It's which instance size are you choosing? Which settings do you have configured? Do you have certain amounts of memory or CPU hardware or different CPU model types that you are using in each individual resource? And so Compute Optimizer does all of that analysis to identify what is the highest performance resource you can be using that satisfies the performance your application needs. And it does that at the lowest possible cost.
I was talking last week at the Paris Summit with a team leader that he was telling me, developers, when they experiment something, they start an EC2 instance, which is too large, too big, and they know it. It's too much memory, too many CPUs, just to be sure, to be safe. That's the type of problem we are trying to solve with Cost Optimizer, the default tendency that humans have to oversize their infrastructure.
Absolutely. It's systemic in our industry, right? It's like when you hire a new developer to your team and you're doing the onboarding process, and you give them the option of selecting their computer when they first join, right? Say if you give them, okay, well, we have the 16 gig model or the 32 gig model, what would you like to do your job?
64.
Yeah, they'll always pick the highest amount of capacity possible. And that's okay, right? Because we want our developers to be super productive and have everything at their fingertips to be great at their job. So this is sort of a necessary and important investment that we make sure the resource is aligned to our talent so we can build great services and products.
But then at scale, it might become a problem for customers that have dozens of accounts, hundreds of accounts.
Yeah, when you have hundreds or thousands of developers or even a dozen, right, the scale problem gets difficult to manage. But, when a developer is given a task to build a great product or a new feature or something, performance matters a great deal, right? You're always looking to make sure that what you're building is resilient, is powerful, it has low load times, low latency. It's the beauty of engineering a great product is it's efficient and effective. So we index more on performance in general when we build new services. And there's this added task that is maybe an afterthought a lot of times, which is, are you going back and revisiting the design decisions you made and the resourcing decisions you made to validate, okay, yeah, we don't really need that size. Now we know what the real world performance demands are of this application. Okay, now we can pick a cheaper or smaller instance type or, a different CPU that may be a better fit for this application. And so that second order optimization is generally not in your backlog.
It should be. Yeah, I mean, it should be part of your story or your backlog to think about optimization. But there is one additional challenge in the cloud, is that an infrastructure, it's like a living organism. It grows, it shrinks, it changes. So we might left some things behind us. I'm thinking about unused EBS volumes, backup, AMI that we are not using, and over time these tends to accumulate and increase the pressure on on the bill as well.
It does, or when you have an engineering team that switches to a new project, right? And maybe the previous project was left in a state where it's like, well, we don't know if we may need these components again in the future, so we'll just leave them there. We might have unattached a bunch of EBS volumes, and they have a certain version of your environment that maybe someday you may need, but converting those to snapshots would be a more cost-effective solution. So who's going to go make the snapshot policies and the lifecycle policies? Like the time and effort it takes to go build some control, some cost control, again, usually cost management and the spend of an account is not the primary job responsibility of our developer resources. So whose job is it, right? You know, who is the CFO going to go, yell at, like, why are EBS costs spiraling out of control? I don't know, like, who knows, right? And so Compute Optimizer is designed to take a look at a lot of those use cases. Unattached EBS is a great one that Compute Optimizer does as well. And hey, we just want to deliver the list. What is the list of unattached EBS volumes? In that case, like Compute Optimizer looks at the historical attachment data and says, any EBS volume that's been unattached for 32 days or more will show up and be called an idle EBS volume. And the recommendation is to just take a snapshot, which is significantly lower cost to have a snapshot than a full running EBS volume, and do your snapshotting and then either delete or, snapshot or not. If it's really resources that are totally not necessary, then just fully delete those resources.
The name says Compute Optimizer, so it's primarily built around compute resource like EC2 and attached resource. You mentioned EBS, you mentioned a database. I guess it's intentional, but where Compute Optimizer fits in the in the family of cost optimization tools and reporting tools and analytics tools that we provide to our customers?
That's a great question. So Compute Optimizer was launched in 2019, and it was primarily an EC2 right-sizing product at that time, really focusing on the problem of identifying CPU, memory, disk, network utilization, comparing it to the different processor types available, and making recommendations to pick the correct instance type and size for each running workload. We've expanded a lot since then. We've expanded into EBS, we've expanded into RDS and Aurora. So the name is a little dated. It's pretty tough when you're at Amazon to change the name of something that has like API namespaces. We don't want to break our customers. In an ideal world, we would be in a situation where we could change the name to something more like Cloud Optimizer or something like that. But it did make its name in the game of EC2 right-sizing. Optimization recommendations. We recently expanded tremendously into auto-scaling groups, which have a lot of technical complexity. That was a really fun project because the technical complexity of measuring the performance difference of dozens or hundreds of different instances with different processor types, normalizing all of that utilization data, and then making recommendations that would increase efficiency. That was quite the engineering project to model that out and apply ML concepts to how we could build a recommendation around it. That came out just in January, I believe.
What type of recommendation it does on auto-scaling group, like maximum size, recommended size of a group, but also instance type
so instance type primarily, and it'll look at all of the historical scaling that has happened on your auto-scaling group, how often it goes up, how often it goes down, and without actually changing your minimum and maximum, because a lot of times those are set for more business or resiliency reasons than performance reasons. What it'll do is it'll simulate what would happen within your current minimum and maximum with a newer, faster, more performant instance type. So we're running simulations based on, okay, well, what if we put in an M7 or an M8 or an R8? And what would happen? How many running hours would you need to fulfill this auto-scaling group based on its past historical usage and utilization with a newer, faster set of instances? And then it does this simulation. It picks the 3 best options for which instance types and families you should add to your auto-scaling group. And then it makes a recommendation to add those to your configuration at the top, at the most highly prioritized spot for each instance type. So if you have 3 instances, you can add 3 of those 3 best options for which instance types and families you should add to your auto-scaling group. And then it makes a recommendation to add those to your configuration at the top, at the most highly prioritized spot for what instance types should be spun up in your auto scaling group. And so it finds the most efficient and highest performance instance types, and then it simulates how many less running hours would your auto scaling group have if it was using those newer, faster instance types. So something like the M8 is something like 30-40% faster than the M7. Okay, so we can take a look at the benchmark data, multiply and come up with a model that we understand you would need X% less instances running at any given time based on the historical utilization. And then we can compare the cost difference between if you were running that new instance type and less of them over time. And even if that individual instance type is more expensive, overall, it may be cheaper because you don't need to run as many of them. Mm-hmm. And that comparison is really important because going to the newest instance types gives you faster application performance. You get maybe DDR5 memory, which has much better latency performance characteristics. Your customers are experiencing faster load times and lower latency, and you're lowering your cost structure at the same time. And that's part of what Compute Optimizer is designed to do. It's not like it's not just a cost savings tool. In fact, we tend to not talk about our product in terms of cost savings when we're building and designing these features. It is a performance management tool to make sure your applications are always healthy and highest performance possible. And it just so happens to save cost because we're not like largely oversizing everything. Once we have really high confidence based on our ML models and analysis that you can safely run, and plus 20% extra headroom and buffer added into our algorithms, and peak analysis, how often are you peaking, and how many samples are peaking. Once we have all of that data, we can have an extremely high confidence that we can run on a new instance type with higher performance and lower cost. And so the whole intent here is maximize the correct fit, and the side effect is lower cost.
So you're partially answered my next question already. How does it work? So you said something very important. It's something that customer needs to enable, and you start to look at the historical data on your account. So what is the type of data? What type of algorithmic are you running? You talk about machine learning, so I guess it's not only algorithmic. You are also training models. Are these generic for all our customers or specific for each customer? How does it work behind the scenes?
Yeah, I'm going to break down a couple parts of the engine. The first sort of more algorithmic set of components is we're looking at 5-minute samples of historical utilization for, let's take EC2, for example. CPU, memory, disk input, disk output, network input, network output. We're also looking at what are the benchmark values of every single type of processor that Compute Optimizer supports, which we support well over 750 different instances in AWS, essentially most all of them except for a couple of outliers where utilization data is not as easy to capture, like Trainium. And then what we're doing is by looking at 5-minute samples across, by default, 14 days, which is, that look back is also configurable to 32 days, or there's a paid feature for 93 days, which is about 25 cents a month per workload. But by using 5-minute samples, we can look at not just what did utilization peak to, which is sort of not that important because if you reboot an instance or apply a patch, you're going to get 100% utilization. What's more important in this analysis is how often do you peak and for how long. That's the trick of right sizing. It's not a game of lowering your peak because you're not going to throw away your laptop and buy a new one every time you boot it up and you hit 100% utilization. That's not that's not computer science. So we're looking at and honing in on how long does your workload peak, and is it getting resource constrained over a period of time that we know would then impact a customer using an application. So in that sort of world, what we're doing is we're applying a little bit of percentile analysis. So for CPU, by default, we use 99.5. And what that means is we take the 99.5th highest 5-minute CPU utilization sample over the last by default 14 days or 32 days or 93, whatever your look back period is. And then we take that 99.5th highest percentile, we add an additional 20% headroom on top of that, because we cannot guarantee future usage is identical to past usage. So we always add a little bit of a headroom safety. And what that means is, like in a common language, we want CPU utilization to be below 80%, which is minus the 20% buffer, for more than 99.5% of the time. And what that ends up looking like is most recommendations where average utilization is 5, 10, 20%. The recommendation may move your average utilization up a little bit, maybe to 15 or 20%, because it's still largely getting the peaks below an 80% sort of range. And when we're looking at 5-minute samples, we're looking at 5-minute peak or 5-minute max samples. So we're extremely conservative with which samples we're selecting. And then we apply percentile, and then we apply buffer, and then we also apply the benchmark values of the performance differences between all of those processor models, between Intel, AMD, Graviton, right? So that's another safety net. So all in all, like this process has multiple safety nets throughout each of the processes, because at the end of the day, performance matters a great deal more than cost. Otherwise, we would just size everything to a T2 Nano and move on, right? Which isn't reasonable. So we're really looking for, how do we serve performance first? There's also a few other components of our engine. We have an ML model engine that models out bursting credits. There's some instance families that have bursting credits, like the T series family. The M7i Flex series also has bursting credits. So we have an ML model that will simulate, if you take a size change, what is the % chance that you run out of bursting credits? And that's analyzing historically what percentage of time are you above the baseline and consuming credits historically, and then what would that look like in the future, plus a buffer. And so we run these ML models to simulate what are the % chance odds of running out of burst credits. And anything that has a % chance to run out of a burst credit above 0%, we pull out of the recommendation results. So we're essentially never recommending a burstable instance if we ever think there's any risk whatsoever of running out of those credits and therefore having a performance impact. And there's a few other ML models in the end-to-end engine as well. But those are just some examples of the safety nets and the engines we have in the recommendation model for just EC2.
And you said at the beginning that it's free. Customer needs to enable it, but in the most the first version, I don't want to say the most basic version because it's not basic what you're explaining at all, but the first level is for free. I'm a bit surprised with that because everything that you describe implies some pressure on our infrastructure. There is a cost for us to run this optimization and this computation, and usually when there is a cost for us, there is a price for the customers as well. Here we decide to make this recommendation for free.
Yeah, we realize that a highly efficient environment is a healthy environment for our customers. And I mean, this is sort of the purpose why my team exists, is we're here to help make sure people are getting great value out of AWS, right? We're not happy when a customer's not happy. We're not happy when a customer is not efficient and satisfied that their environment and their set configuration is less performant as it could be. That's the point of my organization and what we do on a daily basis is we look through all of the optimization opportunities and identify how else can we help our customers have great success with AWS. Not everybody has a long tenured background on AWS and knows the performance difference of all these different instance types and can easily pick between them. There's just too many instance types out there now, and we want to help. And it's important because those performance characteristics of these different instance families can be pretty drastic in a lot of cases. So it's a fun job, I'll tell you that. Like building free tools to help people save money, like it's kind of my dream job. So I enjoy the heck out of it.
Yeah, it's a bit counterintuitive that we help customers to save money, but at the end, what we want is a long-term relationship.
That's right.
So we
That's
need to
right.
be sure that
And
customers
it's pretty
are paying
exciting.
the right price.
Andy Jassy in his quarterly earnings reports, he talks about how
Mm-hmm.
important it is to help customers optimize all the time. He, during the COVID timeframe, almost every quarterly report, he was talking about how we're helping customers optimize, and it's it feels good. It feels good to know that the work you're putting in is important and strategic to the company, right?
If it is free, why we don't flip it on by default?
Yeah, that's a great question. I mean, there's a lot of reasons why. I'm constantly working with customers to turn it on. We utilize sometimes in some of the recommendations the customer data. And what I mean by that is if you are installing CloudWatch agents to get memory data, Compute Optimizer will take that memory data to build a better recommendation. If you turn on memory data, the recommendations will save you 400% plus more money, because if there's not memory data, Compute Optimizer will not recommend downsizing on memory capacity, because again, the whole point is not to have any performance risk. And so if you're already at, say, a 32 gig instance, and say you're at the cheapest 32 gig instance, or largely there's very little cost variation at their 32 gig instance types, if you don't have memory data in Compute Optimizer, it will not recommend going below. And so there's sort of a missing savings potential. So if you go add memory data, that's unlocked. Compute Optimizer increases its value pretty significantly with that memory data. But that is customer data. And it's important for us to honor and respect customer data. And so the opt-in is basically giving us permission to look at your memory utilization data and then make recommendations based on it. And it is a regional service, so that data stays in the region that it originated in. And we don't move it across regions or anything like that, but it still does require that opt-in to make sure that we're getting permission to allow customers to grant Compute Optimizer that access to memory data to make those recommendations.
What are the prerequisites to turn it on? Obviously, we need a couple of weeks of previous data for brand new workload. It will not work. We need to enable CloudWatch logs, install CloudWatch agents if we want to collect memory. What else?
Actually, it's less than that. We will actually pull the default utilization values from CloudWatch that historically exist for all of the resources already. So if you turn on Compute Optimizer, we will go get that historical utilization data for those resources. And we also provide some customization capability, which we heard from a lot of developers that, okay, you're using sensitivity settings that maybe I want different ones. So, if you were using 20% extra buffer by default, well, what if I want 30 or 0, right? And so we provided those as tunable options in the product. But when you turn on Compute Optimizer, it takes about a day for it to pull all of the historical utilization data and generate the first set of recommendations. But they will be based on whatever settings you have within 1 day after you make those settings changes. So if you say, I want 32 days of utilization data in all my recommendations, you can go into the tool, set 32 days as your preference for how much look-back period you want. And the next time those recommendations regenerate, they will be based on 32 days of historical utilization. You don't have to wait 32 days. That data is in CloudWatch already. We query that. There's no additional cost to you for those CloudWatch queries. That's an internal process that our tool pulls that data from CloudWatch from. So there's no API calls or queries necessarily from that. The only cost associated to Compute Optimizer is, one, if you enable 93 days of history, there's a marginal cost there, roughly 25 cents a month per workload. And then if you enable memory metrics via CloudWatch, there is CloudWatch costs associated with gathering those memory metrics.
Yes.
But you can also set rule sets to only retain a small amount of historical data on the memory data, for example, and keep costs very low for CloudWatch.
So the tool service is going to make recommendation. Of course, it will not apply the recommendation because that might involve a downtime. Let's think about right-sizing a database, for example. We need to shut it down and restart it. So what is the output of the tool? It's in the console or through the API, a list of proposed changes?
That's right. either console or API. And a lot of customers will pull all of the recommendations via API and put them into their own dashboard, break them down by their organizational boundaries or whatever reporting or org structure you want. In the console, of course, you can filter by tags or look at by account or region or quite a few other filter options. But it gives you that recommendation for each resource and sometimes multiple recommendations, because you might have a resource that is idle and there's either, or maybe both, an idle recommendation saying this does not look like any usage whatsoever is occurring on this instance. You could snapshot and delete it, or right size it. Like if you expect it, maybe utilization is intended to be low, you can right size it. Or if it really is unused and you have no future plans for it, you can delete it. So there's maybe multiple recommendations on a single instance sometimes. But the recommendation details will show you the historical utilization for all of the different counters that went into the recommendation. So CPU, memory, disk, network, both input and output. If you have something like RDS Performance Insights enabled, you'll see query performance data, you'll see memory pressure type data sets. So it's pretty expansive. All the data that goes into how the recommendation is generated is also shown to you. And then it'll show you 3 recommended options. It'll start with the lowest performance risk first, kind of our ideal instance that we think is the best price to performance ratio that fits the performance needs. But then it'll also show you some other options. Like if you're interested in Graviton, you can flip the Graviton filter and take a look at what would this cost if I switched to a Graviton instance type, which may be a decision you want to make if you are interested in the better price to performance ratio of the Graviton instances and say your application is compatible. That's a really great optimization to go after. There's other ways to look at this too. Like you can say, okay, I want to configure Compute Optimizer to only recommend certain instance types or families. That's a configurable option as well. And once you make those configuration choices, you'll see that reflected in the end result recommendation. The recommendation also shows you what your settings are. So if you have set like maybe a higher buffer or a lower percentile or longer look back period, every time we generate a recommendation, we're showing you what criteria and thresholds were used in the generation process. There's also another ML model in the product called Inferred Workload. And this is really cool. EC2 team works with us on this. We're doing all sorts of inference and identification of what type of workload you're running. And so there's a really cool field in Compute Optimizer that will show you with pretty high accuracy based on utilization data, tag data, whatever, what we think is running on that instance to help you more quickly identify, okay, here's a SQL workload. Okay, these SQL workloads are sort of more memory intensive, and so we want to keep them on memory focused SKUs or things like that. And that data is all in each recommendation result as well.
Is there a way for a customer to push notification to something else, like EventBridge or SNS? I'm thinking about automation. We can imagine customer opening a ticket, linking this to Jira, including that in their stories.
I've seen customers do so many interesting ways to integrate the recommendations, whether that's like CI/CD pipelines or auto ticket creation processes when a new recommendation shows up. There's some really nice open source Git repos that have some execution components in them as well. So it's really cool to see when engineers like take what you're building and they build on top of it. And that's sort of the point of Compute Optimizer. Like it's an API based product that is easy to query, free to query. So we have a large number of customers that build their own optimization programs and projects and software on top of our recommendations. There's actually even some third-party products that will take the Compute Optimizer recommendations and add automation on top of them and have great success there as well. So it's exciting to see that by providing optimization as a service, anybody can use this. Anybody can increase the efficiency of their environment and the performance of their environment, whatever their environment's like, whether that's, hey, we've got a powerful CI/CD pipeline for our whole company, or whether that's, okay, we have an ITSM ticketing system, whatever your pipeline is for change control and change management, there's people out there with blogs and open source methods for how they've embedded Compute Optimizer into those processes. And it's really exciting to see how they've done it.
What's the scope of the recommendation? You mentioned it's a regional tool, so it's at least the maximum boundary, I guess, it's a region, but can I be more specific and target specific workloads or easy or type of instance of tags?
So yeah, we try to do that with like great filtering options in Compute Optimizer. So we filter by tag, key, and value pair, by region, by account. You can clearly export it into a CSV and do whatever you want with the data. So a lot of people do that. Or they build their own dashboards if they have other filtration, or I've seen a lot of companies will join it with their org reporting, right? So you know who owns which resource. Now, sometimes companies use tags to identify ownership and business units and things like that. Sometimes they have their own mechanism. So there's quite a few ways to do it. But the whole intent of Compute Optimizer is to provide the most accurate and most granular data sets on the individual recommendations. But then also the scale of it, where you might have hundreds or thousands of accounts if you're in a big company, and you can enable Compute Optimizer at the AWS orgs level and essentially just turn it on for your whole company in a couple of clicks.
All the accounts.
Yeah, so you can just go like bulk enable this thing across your company. You can also bulk edit and change the settings. So if you want 32 days by default across your entire company, that's just a few clicks. Like if you have sort of like this agreement that your company wants to do right sizing with maybe a certain sensitivity. Now by default, 99.5 percentile is very conservative and very, very safe in order to be like provide recommendations that are very production safe. But say for non-production, you can list out all of your non-production accounts and set it to 95th or 90th percentile to get more savings. And so like these bulk controls allow you to set these preferences on groups of accounts or many accounts at a time. People have scripted that out with API calls, but it's also there in the console.
But at the end, we make recommendation that customer can apply, can follow. And you mentioned the great care that your team took to ensure that these recommendations are trusted, are valid. Because if they make the change, the new infrastructure still has to work. And it's one of our leadership principles at Amazon. And trust, is trust really the centerpiece of this service?
It sure is. If somebody took a recommendation and it broke something, they'd probably never use the product again. And so trust is at the centerpiece of every feature we launch, every project we do. Not just trust in the recommendation, but trust in how can I use this data in my optimization program? How can I, maybe if I only have 5 minutes, how can I take a recommendation that is extremely low risk? How do we think of risk? How do we think of low risk versus high risk in a recommendation? Like an example would be EBS recommendations. If you take EBS recommendations, it'll show in the product that there's no downtime and there's no performance risk because you can just easily roll back if you don't like it. And by going from GP2 to GP3, the baseline IOPS actually increases. And so you can take these recommendations, get a performance uplift and a cost reduction, and there's no downtime and essentially no risk associated with that change. And so we've had some customers that have just taken like bulk every EBS recommendation out of the tool, just execute them all, and boom, you get a nice reduction on your EBS costs in 1-2 days. And that's the sort of thing we like to see, because when you're getting started on your optimization program and you're like trying to cut costs, there is some low-hanging fruit. There's some lower risk stuff. Taking an EC2 right size change is disruptive. You have to reboot the instance. Maybe you don't have an application that has like great resiliency or failover. But there are some recommendations that are easier and they don't require quite so much analysis to say, how can I fit this into my environment? EBS is one example. There are others. There's like some of those storage recommendations on RDS as well that don't have any downtime or impact. And so understanding the performance risk or change risk associated with these recommendations can help you get started. Because if you're like, okay, my leadership is complaining about cost and I've got to fit this into my backlog, there are easy things you can do that won't take a lot of time or effort to go relieve pressure on cost. And it does not take re-architecture. You do not need to redesign your application and move to Graviton to save money. That is a great option, but that may be a fairly effort-intensive option to go analyze your architecture and the compatibility. Just changing EC2 instances and staying on x86 architecture does not require any sort of architectural change or analysis. You're just moving to a faster processor. That's fairly low risk in comparison to something like Graviton. But then, even one step lower are things like EBS recommendations, where there's no downtime whatsoever. And so we see customers go through this optimization maturity. You start with the low-hanging fruit. You take a nice 20+% reduction on EBS costs by getting those sized correctly based on your utilization. And then you kind of get people used to this idea that cloud is designed for continuous change. It is designed for size changes to be effortless and meaningful. The whole point is that if you provision something 10 years ago, there's nothing stopping you from changing that instance type or size today. And you just, in a couple of minutes, get a 10-year jump on performance and hardware, essentially for almost no effort, right? And so this is the power of cloud. We do not want to treat cloud like a data center. We do not want to provision everything and just sort of let it sit. We want it to be elastic. We want it to be scalable, and we want to take advantage of this power that every time AWS works with a provider like Intel or AMD or builds something like Graviton, everybody can get the benefits of these new hardware components that are being launched. Same thing with like an AI ML model. You can switch models pretty easily and effortlessly. Like that same idea that we are all in this industry together maturing, and let's make sure all of our applications or systems are staying with us as new technology is launched and evolved.
Is there any approved metric that you can share about the number of recommendations that we or the service made since the launch of the service, or the cost optimization, the potential cost optimization that customer could have applied?
Yes, there's some approved metrics. So that when I mentioned how much more savings you can get when you add memory metrics, there's over 370% additional savings when you add memory metrics to Compute Optimizer.
Wow.
And another metric we like to talk about is how many recommendations we've generated for customers, which is well over 2 billion recommendations. Yeah, it's pretty exciting running a system at this scale that's global for all of our customers, and helping people run cloud and run their architecture efficiently. It's a fun job, and having something like 2 billion plus recommendations delivered is sort of just evidence that we can help, and we can use ML, we can use logic engines, and of course, looking forward, Gen AI and how we embed and incorporate that into what we're doing in the future.
That's exactly my next question. Okay. What's next? Because we talk about the origin, how it works, the benefits for customer. I know we are not disclosing our roadmap, but what are the trends or the tendencies? That
so AI and FinOps is a big conversation. It's something that we are constantly thinking about and looking at. Okay, what are the ways to incorporate Gen AI into our products? We don't necessarily want to hand over the recommendation generation components to Gen AI because obviously, like, there's some issues with
hallucination
math and hallucination. So we're not looking at it from that perspective quite so much. It's probably not the right tool for the job. We don't want to just paint AI over everything, right? But there are some opportunities with Gen AI where a lot of people are trying to look at these recommendations and make sense of them, and they're like, okay, but why this CPU model? Why not this other one? And some deep dive questions on why did your system come up with this specific recommendation that it looks like Gen AI can help explain how our logic arrived at the end result recommendation. So that's something we're thinking about. Like, what is the future of helping somebody that may be new to recommendations and new to optimization get comfortable? And so that's something that, like, we're working through. Like, what does that look like? There's other areas that we're investigating. Like, recently we launched the Autoscaling Group recommendation, like I mentioned. We launched Aurora recommendations for optimization at reInvent timeframe. We launched RDS mid last year. So we're constantly launching new recommendations and talking to customers about, like, in your AWS bill, what areas do you not have enough optimization visibility into? Where do you need help? And those customer conversations lead to our backlog. And those are fun conversations. We're talking to really brilliant engineers all the time about, okay, we're trying to build these types of systems. There's sort of a pattern, an architectural pattern we're using. And so these services are important to us to make sure we're running them efficiently. And that informs our backlog. We also look at what services historically have had the most amount of, like, customer adoption and attention. Those are areas we want to investigate and say, like, how easy is it to make a right size recommendation? Can we deliver something that has material value, that is easy to take? We'll notice that things like an EBS recommendation that has no downtime will have higher adoption because there's less analysis that goes into it. So what other types of recommendations can we build that have maybe a lower bar for required analysis or architectural impact that we can go build and go help the industry sort of move past? Because personally, I don't want engineers to spend a lot of time doing a bunch of EBS idle analysis. We want developers developing and building awesome things. So we want to take care of the things like the idle analysis for you and just deliver you, hey, here's the list. Here, like, go for it. Do what you want with this list. Here is the list that meets the criteria. And by the way, you can change the criteria. It's on you to figure out, do you like this criteria? Do you agree with it? You set the criteria, and we'll just do all of that analysis for you and deliver you the results. And at the end of the day, it's only going to take you maybe 5 minutes to, like, look at the last list and say, yep, those are all idle, and go clean them up.
All good, and go. That's the undifferentiated heavy lifting that Werner is constantly talking about in its conference and keynote. Are there families of resource, types of resource that are very hard or impossible to optimize? I'm thinking about maybe networking, cross-AZ, traffic, NAT gateway.
There are some, yes. Network is a challenge because the way you have architected your application may or may not be utilizing network efficiently, and that is a harder thing to detect from just pure telemetry. There are maybe some design decisions that an application has made that may result in higher network costs that may be acceptable decisions. And this is sort of an issue that we run up against in a lot of recommendation models and scenarios where you may be intentionally designing a system less efficient than it could be. But maybe there's good reasons for that. Maybe you are running an active-passive failover on EC2. From our vantage point, looking at the utilization metrics, it looks like you have a whole lot of idle EC2 instances. But from your perspective, they're not idle. That's a hot standby environment, right?
It's a design decision.
And those design decisions are difficult to detect just purely from a scientific perspective. So whenever there's, like, business decisions related to uptime, failover, like, we do our best to detect those. Like, we launched idle recommendations for RDS. And one of the things we did in that when we were developing this recommendation is we look to see if the RDS instance is a read-only database read replica. And if it is, we automatically move past it and do not mark it as idle, even though a lot of times they are, because we can recognize from metadata that you've got it configured that way intentionally. And so we look for those opportunities to identify and improve the accuracy of our recommendations to avoid false positives as much as we possibly can. And having deep thinking and analysis on all the false positives is very important for every recommendation we deliver to make sure you can trust those recommendations without quite so much manual investigation and validation.
AWS Compute Optimizer, it's free, so go to the console today and enable it, or use the command line. You can enable it and start increasing that impressive count of more than 2 billion recommendations that have been made since we launched that service a couple of years ago. Thank you, Rick, for your very clear, very structured explanation about how to optimize for performance and not only for cost. You explained really well cost. It's a side effect, a nice side effect of optimizing for performance as well. Thank you for having listened this episode until the end. See you next week in all your good podcast application. But now go build.